Hi class, the next thing I need you to take a look at here is the second half of section 5.3, which involves what's called the point ratio form of a curve. Point ratio form is basically a way that we can find the equation of a curve without knowing the y-intercept a. And if you think back to Unit 2 when we were talking about lines, we did this back then as well. We had one form of a line which was called the slope-intercept form. And the slope-intercept form had you write the equation of a line when you knew the y-intercept a and the slope b. Then we introduced the point-slope form of a line where you knew the slope of it, b, or you could at least calculate the slope given 2 points, but then instead of relying on the y-intercept, you could use any point on the line called x1, y1. Well, we sort of come to that point today with exponentials, where earlier this week and last week we talked about exponential equations where we knew that a was the y-intercept. Okay, a is the y-intercept of the curve rather than the line. And our general form of an exponential is y equals ab to the x power. Well, today we're going to take a look at finding the equation of a curve when you don't necessarily know its y-intercept, but you know any point on the curve, and this is what's called point ratio form of a curve. If an exponential curve passes through any point, let's call it x1, y1. So there it is, any general point on the curve, x1, y1. And the function values have ratio b for values of x that differ by 1. So they're saying that that common ratio, as x goes up by 1, the common ratio is b. Then the point ratio form of the equation is y equals y1 times b to the x minus x1. So let's make sure we get that in our notes right there. Y equals y1 times b to the x minus x1 power. So y1 is in place of our a, and instead of just taking b to the x power, it's to the x minus x1 power. Little paragraph there. If you'd like to read it and pause it, go for it. I'm going to move on to the next slide, which is our example. Casey hit the bell in the school clock tower. Her pressure reader held nearby measured the sound intensity or loudness at 40 pounds per square inch after 4 seconds had elapsed, and at 4.7 pounds per square inch after 7.2 seconds had elapsed. She remembers from her science class that sound decays exponentially. So we know that our graph will be of exponential decay and look like that. We know that we're going to have our y equals ab to the x. I'm just thinking out loud here. Sorry about that. Our ab to the x is going to have a b value less than 1 because they tell us that it's exponential decay. Part A, name 2 points that this exponential curve definitely goes through. Well, it needs to go through 4 seconds, 40 pounds per square inch, and 7.2 seconds, 4.7 pounds per square inch. So we know that those are the 2 points on the curve. Find an exponential equation that models these data. Since we don't know the y-intercept, they're not giving us 0, something, we're going to have to use what's called point ratio form. Y equals y1 times b to the x minus x1 power. So we have y equals, I'm going to choose the y1 40. We don't know what b is, but the x1 that goes along with that y1 of 40 is 4. Next, we're going to use the other point, let's call it x2, y2, to make another equation. In this one, 4.7 is our y. That goes where a normally goes. B is unknown at this point. Now, in this exponent, we have x minus 7.2 because that's the x value. That's the x value that goes with our given y value, 4.7. We don't have the exponential equation yet. To find the exponential equation, we actually need to solve for the b. So I'm going to get you set up with this. And I want you to try to finish parts B and C for homework tonight. But basically, now that we know that this equation equals y, and this equation equals y. Let's set it up so that those two equations equal each other. 40 times b to the x minus 4 can be set equal to 4.7 times b to the x minus 7.2. I want you to try to think of some strategies that you can use to solve for b here. Once you find the b, you can go back and plug it into the equation and use either one as your exponential model for part b. For part c, you would then use that equation that you found. Once you know the b, it's going to be the tricky part. Finishing this part right here where you have to solve for that b, try to get b by itself. You can do part c simply by plugging in 0 for x. So good luck with that. When you come into class tomorrow, I'm going to ask that we share our methods here for finding b. Thanks. And that's basically it for tonight. No other homework other than to finish this example.